All right, you guys, welcome back. It's Miss Markell. Today we're going to be talking about the motion of particles. And our experiment is observing phenomena. For today, we're really going to look at how atoms and molecules move in solids, liquids, and gases. Looking at my experiment setup, I don't see any gases or solids. So let's see what we have here. If we were in the school, we would have a beaker. So Miss Markell is using a 4-cup measuring cup. This is a room temperature water. We have some food coloring, and for this experiment, it's yellow and blue. And right along here, I also have a bowl of ice. Hey you guys, all right, so we're gonna start right now with sample A. Sample A is a measuring cup with room temperature water, and now we're going to add some ice to make some ice water, and I want to make sure we give it enough time for that water to get cold. So for your Google Doc, go ahead and write in the description for sample A what we have inside, and let me go ahead and stir this just so you guys. I'm gonna stir it with a fork. There you go. Whatever works. I'm not a scientist. So we have our nice cold water, and I'm gonna go ahead and ask you to predict how many minutes, how many seconds do you think it will take for my yellow and blue food coloring to mix and make a beautiful green. Go ahead and type that in. Are you ready, timer? All right. There we go. See how it drops? So make sure you're paying attention to how the motion of the coloring and how the blue is swirling around the yellow. Just make sure you're observing the motion of the food coloring. So I'm gonna go ahead and change the view in a moment for you guys. Definitely not all the way mixed. You can see a lot of clear on the side. Still going. So one of the questions talks about macroscopic behavior. So remember, that's something you can observe, that you can see. So you're going to be thinking about how you observe the colors moving in the different temperatures of water today. And this is our ice water. Still mixing, not quite there yet. I'm trying not to move it. I'm super tempted. Still going. Just disregard the cats eating. Not a scientist, and this is my house. You can see like there's still a really good area right in here that's not mixed up all the way to make that green. Still going. And then, now you guys, when you look in this way, it does look like it's almost about There. Oh, and look at how green that is right there. Perfect. So go ahead and type in the amount of time it took for our ice water to become green. Dun, 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 dun. Thank you. For the next experiment, this will be sample B. For sample B, it is a little bit different. Go ahead and type in the first or the second column what is in sample B. Sorry for squeaky floor. So again, what is in sample B? Type that in. And now I'm curious to know, do you think that sample B will be faster or slower? So put your prediction. How many minutes, how many seconds do you think sample B will take for the drops of yellow and the drops of blue to turn green? Go ahead and type that in now. Awesome. All right, are you ready with the timer, the stopwatch? All right, so not yet, when I get the blue. I love it. All right, you guys, I'm going to put 2 to 3 drops or 4 or 5. It's 99-cent store. It's not the most accurate. And now I'm going to do 2 to 3. Ready with the timer and go. Makes such a cool little design. So again, the drops are dissolving at different rates. This is the room temperature water. We're going at 36 seconds. The front of this jar looks very green to me, but if you could see above, it definitely still has some mixing to do. We're getting to 1 minute. Still, you can see how it hasn't mixed yet. Definitely a lot of clear at the top. This one is just not there yet. All right, what do you think? Do you think it's all green now? You guys, it is a little bit tricky because the top here is white. It's clear. But what do you think, assistant? Is it green? All right, go ahead and log the time. All right, you guys, go ahead and put that into your log, how long it actually took. All right, you guys, here's sample C. If you see, sample C also looks like water, but this time it is hot water. Be ready with the timer, please. So for sample C, go ahead and write your prediction. How long do you think sample C is going to take for all the water to turn green? So the yellow and the blue. And do you think it's going to be quicker or slower than samples A and B? So 1, 2, 3, 4, 5, 6. Really pay attention to how the colors fall and they're bouncing around. And see how it's spreading. fallen a little bit. But I think that water is all green. So he stopped it a little bit slow, but the water is all green. It was probably around 1 minute, 10 seconds mark. Thanks you guys for being a part of this experiment. Now you're going to go ahead and go to your Google Doc and finish typing up your answers in the lesson 4 Observing Phenomenon Experiment. There are 5 questions where you will be explaining and describing what we saw in the video. Hope you all have a great time exploring this phenomenon.